So hi guys, today we are going to solve one more interesting problem from Blind 75 series, which is group anagram. Actually, it's my favorite problem also. The reason because you can apply all the basic what you learned so far in this problem. So now let's directly jump into the problem statement. Before that, make sure that you solved valid anagram problem. If you don't solve, I will just give I button. You can see the solution. Make sure to watch that solution before coming to this problem. Okay, now let's read the problem statement. The problem statement is that you will be given a list of words. Your task is to find the group anagram. You have to identify the similar anagram together and you have to make it as a group. And you just need to return all the different groups which you find in this list. That's what question asks you to do is, if you see the output, let's take this example. If you see eat T8 belongs to similar anagram group because if you remember in the valid anagram video, what we talked is we can just sort them up and we can compare, right? We can use a similar logic here. Now if you take all these three elements and sort them up, you will see the pattern. Just take EAT and you will get AET, and if you sort T again you will get AET. If you sort A again you will get AET. You find a pattern, right? This as a same set of keys, so you can just make them as a one group, one valid anagram group. Again, next you can take NAT. If you sort NAT you will get ANT. Again if you sort TAN, you're going to get again TAN. So this is one of the valid group. That's why you can see NAT and TAN is one valid anagram. Again, at last we have BAT. So if we sort BAT, ABT, and we don't have any other words. So this one makes a valid anagram, this one word. That's why you put BAT in one single array. This is one group, and NAT and TAN is also one group, and A, T, and E is also one valid anagram group. This is what the input and output of the solution is. Now if we talk about the solution, the better solution, there is no brute force. We can directly go to the better solution. If we talk about a better solution, we can apply the similar logic what we discussed here. We can have an HashMap and we can have a unique key. Okay, so let me draw the HashMap how it looks. Yeah, this is how your HashMap looks. What you have to do is the key is going to be our sorted string. Okay, so we discussed here the sorted string is going to be identify the unique group. So now we can just iterate to every single word. Just iterate to this word eat. Now it's just sorted out. Now if you sort this, you will get AET, right? And then just put the word here, EAT. Now just move to the next word. Okay, just move to the next word. If you go, you're going to take T, just sort it out and check whether the keys exist in our HashMap or not. Yes, our sorted keys exist. So just directly add T here. I'll just write here, if you sort EAT, you're going to get AET. And if you're going to take T, you're going to get AET. Now just move to the 8. Again, if you sort 8, you're going to get AET, which is already exist in our HashMap. So directly add this word here. Just move to the next word, NAT. If you take NAT, if you sort it out, you will get ANT. ANT is not present in our HashMap. So add ANT here and add the word also. Now move to the next word, BAT. If you take BAT and sort them out, you will get ABT. So ABT is also not there. So just add ABT here and add the given word, BAT. Now just move to the next word. You're going to get TAN. If you sort TAN, you're going to get ANT. So ANT is already present. So directly add the TAN in this list. At last, you can directly return this entire list. I mean, you can directly return this, guys. That's it. Our answer is done. This is going to be optimal solution. If we see, okay, now let's write pseudocode and then we'll discuss about time complexity. For pseudocode, what we can do is we can declare an HashMap, and then we can iterate every single word for word in words, and you can just sort it out. We can assign a key is going to be sorted of word. You can just sort the word and you just check if key in HashMap. If it's there, you directly going to append the word to this list. You can directly append this word. Okay. Now HashMap of dot append the word. If it's not like this is going to be the first time, create a list and add the current word. That's what we did, right? If it's going to be seen for the first time, we are just going to add the letter, add the list and add the current word. Hash map of key is going to be equal to a list of the word. That's it. And last, we can directly return list of hashmap dot values. This is the simple brute force solution. If you don't understand this, I written very shortly. What you can do is you can declare and result. You can iterate the every single value from the hashmap directly appended. You can return it. That's what I written very shortly here. A list of hashmap dot values. Very simple solution. And if we discuss about time complexity, for sorting it will take n log n time, right? N log n, where n is the length of the word. Okay, and then we are just iterating every single word, so that just multiply m into n log n. This is going to be time, where m is a length of words, how much words, and where n is the length of a particular word. So the overall time complexity is going to be m into n log n, and then space is going to be O of n for the given hash map. We are using hash map, so space is going to be O of n. So this is the better solution. So we can improve this solution also, right? If we talk about optimal solution, what we are going to do in the optimal solution is we're going to reduce the time complexity from m into n log n to the m into n, which is much better compared to this solution. Now we are going to do this. Take an idea from the previous solution. We are just going to optimize it. So what is our previous idea is just take a word, sort it out, make it a unique key, and with the help of unique key, we can directly append the word to the group of anagram. Okay, the key point here is a unique key. So how do you find a unique key without sorting it? That's what you ought to think in this solution, the optimal one. So we can achieve this in one way, which is using the frequency counter. What do you mean by frequency counter is it's just going to count the frequency of every single character in this word. If you take an example, let's take listen. Let's take 8. If we count the frequency, A comes one time, T comes one time, E comes one time. You can ask me how can I form the pattern out of this. That's very simple. Just declare an array size of 26 and you can just mark the frequency here. A came one time, T came one time, and E came one time here, right? And remaining place, make it as 0. Just make it as 0. If you just convert this to a string, you can find a unique pattern. Let me convert to a string. It's going to be 1 0 0. Let's assume this is our pattern which we get from this. So what is the pattern you see here is 1 0 0 1 0 0 0 1 and 0 0 0 0 0. This is the unique pattern for this word. Okay, now if you take another word, if you take T, just mark the frequency. Obviously we're just going to end up with this similar kind of array, by which we can know that this is a part of 8 anagram. 8, and this word is also part of it. It's very simple finding the pattern with this style. And if we take again another example, let's take another example, nat. Okay, if we take a nat, just reinitialize this. Now if you reinitialize the array, you just mark the frequency of it. N is going to come one time, n is going to be 1, and A is going to be 1, and T is going to be 1. Again, if you convert this to a string, you will see the pattern 1 0 0 0 0 0 0 0 0 0 and then 1 0 0 0 0 1. You will end up with similar kind of pattern, and then again you can use this as a unique key and have nat here. And if you take the word tan, if you take the tan and if you do the same process, you will end up into the same set of string, and you can tell that this is part of this group, and you can directly add tan here. I hope you understand this solution. It's very simple. I hope you understand. So just make an array of size 26 and mark the frequency of every single character and finally convert to a string. If you convert to a string, you can find a unique pattern of it, unique pattern out of it, by which you can make a group of anagram. This is a very simple solution. So now let's see the pseudocode for it. We're going to have a result variable. We're going to have again HashMap. We're going to use HashMap, and we're just going to iterate to the every single word in words. And now we are going to have the count, which is going to be size of 26, just default value of 0. Okay, now just iterate to every single character of the word and mark the frequency. For character in word, just mark the frequency, count of ord of character minus ord of a, which is going to be plus plus. If you don't understand what is this, basically this particular thing will gives you the ASCII value. Let's say a, so what is ASCII value of a? It's going to be 96 minus 96, which is going to be give 0 0th index. So a belongs to 0th index. And if you take letter b ASCII value is going to be 97, I guess 97. And if you minus word a, ASCII value of a, and once you form this thing, you can directly make a string out of it. You can directly join it like key, again declare a key, like join them. You can make a key and you can follow the same thing. If key is in HashMap, directly append the word. If not, you can directly declare a list and add the word to it. That's it. Same thing what we did here. You can just similarly copy paste it. This is what entire solution looks like. The same thing which we did there we use sorted to find a unique key. Here we are using count to find a unique key. Now if we talk about time complexity, again it's going to take big O of n, so where n is going to be the list of words, and to find the frequency, again it's going to take m time. So overall time complexity is of n of n into m. And then if we talk about space complexity, again space complexity is going to be of n plus of m. This is the time and space complexity, where m is going to be this frequency. For this we are just going to take O of m space. So overall time complexity is O of n into m, space complexity is O of n into m. That's it for this video. Now let's code this app. Now let's declare our hash map, and as we talked, we iterate to every single word, and we'll count the frequency and we'll convert to a string or a tuple, and we're just going to use this as a unique key and follow the same approach for word in strs, and count is going to be as a default value. We're just going to have 0 with the size of 26. Now we iterate to every single character from the word, and then count the, increase the frequency, odd of character minus odd of a plus equal to 1. That's it. Now we just got our frequency map, and we just need to convert to a string, or you can use tuple, any of those things. Right now I'm going to use tuple. Now let's key is going to be tuple of pattern, and then as we discussed, if key in HashMap we're just directly going to append this word, right? Hash map of key dot append word. If it's not exist, we're just going to add an empty list and add the current word to it. Hash map of key is going to be empty list with the current word. It's pretty simple. Now we can directly return a list of hash map dot values. Now let's run this. We just did some typo. This should be count. You can see it passed all the test cases. Now let's submit it. Yeah, we successfully solved this problem. I hope you guys understand this approach. And thanks for watching till this here. And we'll see in one more interesting problem tomorrow. Until then, bye.